I'm going to make my f of x equal to 2x squared plus 11. I'm going to make that in blue. And I'll make my g of x equal to the square root of 4 minus x. I'll make that in orange. So when we are asked to find f composed with g of x, that means that I am going to take my g function and plug it into f. The other notation you may see is f of g of x. Okay. But remember that g of x is equal to the square root of 4 minus x, which means in my original function, when I had 2x squared plus 11, instead of x squared, I'm going to put in my square root of 4 minus x and include my plus 11. Much like the 10 in the last problem, the 11 doesn't get anybody with him because he doesn't have an x. And I forgot my notation. Sorry, I forgot there is a square on that exponent. So 2 times parenthesis, square root of 4 minus x, close parenthesis, squared plus 11. Now you may remember that when we have the square root of something and we square it, the square root and the square, oops, wrong one. The square root and the square take each other out. Okay. Which means that we are working now with 2 times parentheses, 4 minus x, close parentheses. The square and the square root are gone because they canceled each other out. Plus 11 still along for the ride. Remember, we need to distribute 2 times 4, 2 times negative x, which means that we have 8 minus 2x plus 11. And if we simplify by combining our like terms, we find f composed with g of x is equal to negative 2x plus 19. You could have 19 minus 2x, that's fine. This is just preference for me that I always put in descending order. So we have f composed with g of x. We need to find the domain. So let's start with the domain for g, because that's where we plugged in first. So g of x, he is a radical function, and his index is 2. Remember that little number on the radical, if it's not there, it's a 2. And here, since it's even, that means that we need to take the radicand, what's under the radical, set it greater than or equal to 0, and solve. When we do this, we would get negative x greater than or equal to negative 4, because we subtract the 4 from both sides to move it over. And we're not done yet because the x is not by itself. You will need to divide both sides by negative 1. But remember, whenever you multiply or divide by a negative, we need to flip our sign. So we get x is less than or equal to 4. Again, this is our domain of g. After we find the domain of g, we can look at the domain of f composed with g. Okay. We know the end result is a polynomial, but we look back through our work. Did we have any denominators that weren't accounted for? Did we have any new radicals that we have not already found the domain for? And since we already have all that information accounted for, we've already found the domain of the radical. We didn't have any new radicals in our work. We didn't have any new denominators in our work. Our new guy has no new restrictions. But we still have the old restrictions. The x less than or equal to 4 is still in play. Okay, so x less than or equal to -4 are our restrictions. It's like the baggage that you bring into a relationship with you. Just because you're in a new relationship doesn't mean your baggage goes away. G got into the relationship with F. His baggage doesn't go away. He still says x has to be less than or equal to 4. And F of G, when F is okay with it, he's like, okay, but I have no restrictions for us to use. So x less than or equal to 4. Remember, you can always do a little number line. We would be shading to the left because we're going less. And the less than or equal to means closed bracket. And we find out our domain is negative infinity with a parenthesis, always, on up to 4 with a bracket.